core is the innermost layer where nuclear fission occurs. Next, we have radiative zone. Radiative zone surrounds the core. This zone extends outward about 70% of the sun's radius. Next, we have convection zone. Convection zone is above the radiative zone. This layer is where energy is transported by convection. Next, we have photosphere. This is visible surface of the sun where sunlight is emitted. Next, we have chromosphere located above the photosphere. This layer is about 2,000 kilometers thick and has temperature ranging from 4,500 to 20,000 degrees Celsius. And the last one is corona. Corona is the outermost layer. The corona extends millions of kilometers into space and is much hotter than the layers below it.
Number 2, phenomena that occur on the surface of the sun. There are few phenomena such as granules, sunspots, solar cycles, prominence, solar flare, coronal mass ejection, and solar wind. Firstly, I will be explaining about the granule, sunspot, and solar cycle. The photosphere in the sun's atmosphere is made up of granules which appear as grainy structures. The granules are the upper part of the convection zone of the plasma, which is extremely hot with a temperature as high as 5,100 Celsius. The average diameter of a granule is about 1,000 kilometers. Next, sunspot. Sunspots are the dark regions seen on the surface of the sun. Sunspots appear dark because their temperatures are lower than their surrounding area, which are made up of granules. Sunspots are the location of very large eruption in the photosphere. This phenomenon may last more than a week. Sunspots are phenomena that always exist in pairs of groups. The activity of the sunspot seems to appear and disappear according to a cycle that lasts 11 years, known as the solar cycle.
Prominence. A prominence is a huge loop or arch column of glowing gases over the sunspot. Prominences can reach heights of hundreds of thousands of kilometers and may last for several days or months. Prominences that are very strong can throw out matter from the sun into the space at speeds ranging from 600 km per second to more than 1,000 km per second. Coronal mass ejection. A coronal mass ejection is a huge cloud of plasma that erupts from the sun and often occurs together with solar flares, which are huge and strong. A coronal mass ejection is an ejection of magnetic gas particles. The coronal mass ejection spouts magnetic particles at high speeds into outer space and appears like an expanding cloud. These magnetic particles from the coronal mass ejection take 3 days to reach Earth. Like the charged gas particles in solar flares, the magnetic gas particles also react with atoms and molecules in Earth's atmosphere to produce aurora.
Solar flare. A solar flare is a column of large amounts of charged gases erupting from the sun and often occurs near sunspots. Solar flares are strong and spectacular explosions of gases. Solar flares attain their maximum brightness level within a few seconds or minutes and then become dim after a few minutes or hours. Solar flares spout charged gas particles at high speed into outer space. The light from solar flares, which is at the speed of light, takes 8 minutes to reach Earth, while the charged gas particle takes 10 minutes. These charged gas particles often collide with atoms and molecules in Earth's atmosphere to produce a stunning light display in the sky known as aurora, which uniquely occurs only in the airspace around Earth's pole. Lastly, solar wind. Particles in plasma such as electrons, protons, and alpha particles that erupt from the sun to outer space travel together at high speeds, known as solar wind. Solar wind also carries the interplanetary magnetic field along with it. The speed of solar wind is supersonic, with values ranging from 250 km per second to 750 km per second. However, the speed, temperature, and density of the solar wind changes along the course of its movement.
Earth magnetosphere and its importance. Shape of Earth magnetosphere. Firstly, we have Earth magnetosphere. Secondly, we have Earth magnetic field. Compare and contrast the pattern of magnetic field lines between Earth magnetic field and Earth magnetosphere. Even though both have these patterns of magnetic field lines are not fixed, the pattern of the Earth magnetic field lines change slightly, while the pattern of the magnetic field lines in the magnetosphere change a lot based on the interaction between solar wind and Earth magnetic field. Definition of Earth magnetosphere. Earth magnetosphere is defined as a region in outer space surrounding Earth with a magnetic field. In Earth magnetosphere is a combination of Earth magnetic field and the magnetic field in the region in outer space. Next, we have formation of Earth magnetosphere. Magnetosphere is formed by the interaction between the magnetic field brought by the solar wind and Earth magnetic field. As the number and energy of particles brought by the solar wind change, the shape of the magnetosphere also changes. Importance of Earth magnetosphere. It functions as a biological shield to protect life on Earth from the adverse effects of solar wind. It also blocks charged particles such as electrons, protons, and alpha particles in the solar wind from reaching Earth. Excessive numbers of charged particles in Earth's atmosphere will disrupt telecommunication, navigation system, and electric power lines. It also reduces the pressure exerted by solar wind on Earth's atmosphere. Space weather. Space weather and its effect on Earth. Space weather is defined as the phenomena that occur on the surface of the sun, such as solar flares, prominences, sunspot, and coronal mass ejections. It also occurs in space, such as solar wind, solar radiation storm, and geomagnetic storm. Next, we have interpretation of data on space weather. Data on space weather is used or analyzed to forecast when coronal mass ejections occur in the sun. It also determines the reason for the occurrence of solar flares and coronal mass ejections on the surface of the sun.
Here are some fun facts about this chapter.
Yeah. How is helium produced in the sun?
The sun consists almost entirely of two types of gases, which is hydrogen and helium. Rifat, how about aurora?
Aurora is a natural light display in Earth's sky, predominantly seen in high latitude regions. Auroras display dynamic patterns of brilliant lights that appear as curtains, rays, spirals, or dynamic flickers covering the entire sky.
Nice.